Welcome to the DIY Honda Garage channel. The DTC code P1659 indicates an ETCS control relay off malfunction in the 2016 to 2022 Honda HRV. ETCS stands for Electronic Throttle Control System, which is a critical component that manages the throttle position and ensures optimal engine performance. The control relay is an electrical device that facilitates the operation of the ETCS, and its malfunction can cause various performance issues. This specific error code is triggered when the control relay fails to function correctly, resulting in potential drivability concerns. To effectively diagnose and remedy this issue, a systematic troubleshooting approach is required to identify the underlying causes of the malfunction and to restore proper functionality to the vehicle's electronic throttle control system. The DTC P1659 specifically refers to a malfunction in the Electronic Throttle Control System, or ETCS control relay. The ETCS control relay is a fundamental component located in the underhood fuse relay box and is responsible for regulating the power supply to the throttle actuator. This relay is critical in ensuring the vehicle's throttle responds appropriately to the driver's input, facilitating smooth acceleration and deceleration. The malfunction can lead to inconsistency in throttle response. Inspecting this component thoroughly during diagnostics is crucial, as its failure could cascade into broader engine management issues. Moreover, understanding its physical location as part of the electrical system is vital for effective troubleshooting. When dealing with DTC P1659, several potential causes should be considered. Firstly, a faulty ETCS control relay can directly result in this error code, as a malfunctioning relay would not permit adequate power flow to the throttle system. Additionally, open circuits in the wiring harness leading to the relay or among essential components can contribute to the error, potentially severing power or signal continuity necessary for the relay to function. Lastly, shorted wires in the electrical circuit could also be the culprit, leading to unintended connections that impair the control relay's function. Thorough investigation of these components is necessary for accurate troubleshooting and resolution. The symptoms associated with DTC P1659 often manifest as noticeable drivability issues. A significant symptom includes reduced throttle response, where acceleration may feel sluggish or unresponsive due to the malfunction of the control relay. Additionally, the check engine light will typically illuminate on the dashboard, alerting the driver to the vehicle's issues. In some cases, drivers may experience intermittent engine performance problems, meaning there may be sporadic stalling or hesitation while driving. Being aware of these symptoms can help in the quick identification of the issue, prompting timely intervention and reducing the risk of further damage to the vehicle's engine management system. Commencing the troubleshooting process for DTC P1659 begins with verifying the problem using a Honda Diagnostics System, or HDS. First, turn the vehicle to the on position without starting the engine to activate all electronic systems. Next, clear any existing diagnostic trouble codes using the HDS tool. This step will ensure that you are working with current data. After clearing, check for any pending or confirmed DTCs. A confirmed DTC is currently active, while a pending DTC suggests the issue has not yet fully manifested. Depending on whether P1659 reappears as confirmed, you can determine if further action is required, or if the vehicle might be experiencing intermittent issues, which could indicate a need for a closer inspection of electrical connections. The next step in addressing DTC P1659 involves checking the vehicle's fuses, particularly fuse number B4, which is rated at 15 amps and is located in the underhood fuse relay box. To perform this check, first, turn the vehicle to the off lock position to ensure safety during inspection. Examine fuse number B4 for any signs of damage or a blown fuse, as this could directly impact the functionality of the ETCS control relay. If the fuse appears damaged or has continuity issues, replacement is necessary, and this could potentially resolve the DTC issue. However, if the fuse is intact, proceed to the next troubleshooting step to investigate other potential causes of the error. In Step 3, the troubleshooting focuses on the ETCS control relay itself. Begin by safely removing the ETCS control relay from its socket within the underhood fuse relay box. After you have removed the relay, conduct a functional test to verify its operational status. This testing can involve checking for continuity or using a multimeter to ensure it meets specified resistance levels. If the ETCS control relay passes the test, it is deemed functional, and you will proceed to Step 4 to check other components. However, should it fail the test, replacing the relay will be necessary, as a malfunctioning relay will hamper the electronic throttle control system and trigger the DTC. The fourth troubleshooting step involves verifying the voltage supply to the ETCS control relay. Turn the vehicle to on mode while keeping the relay disconnected. At this stage, measure the voltage between two test points, the ETCS control relay's 4P socket number 3 and a reliable body ground. This measurement is critical to determine whether battery voltage is present at the relay socket. If you detect battery voltage, this indicates that the wiring up to the relay is functioning correctly, allowing you to move on to Step 5. Conversely, if no voltage is present, it will be necessary to replace the underhood fuse/relay box, as it may be preventing electrical flow necessary for the relay's operation. Step 5 involves an open wire check for the +B dBW line, which is crucial for the relay's functionality. Begin by turning the vehicle to the off lock position for safety. Similar to previous checks, measure the voltage at specific test points. The ETCS control relay's 4P socket number 1 and another body ground. This measurement needs to take place with the ETCS relay disconnected. If you ascertain that battery voltage exists at this checkpoint, the +B dBW line is intact. If there is no voltage, it indicates an open in the wiring, necessitating a repair of the +B dBW wire between the B4 fuse and the ETCS control relay. Or, if required, the underhood fuse relay box may need replacement. The sixth troubleshooting step requires utilizing the Honda Diagnostic System to jump the SCS line, while also disconnecting the PCM connector C. This is critical for isolating the VBDW dBWROY outline. With the vehicle still in the off-lock mode and the ETCS control relay disconnected, check for continuity between the ETCS control relay's 4P socket number 2 and the PCM connector C. This involves using a multimeter to test the electrical pathways accurately. If continuity is confirmed, it illustrates that the VBDW dBWROY outwire is functioning properly. However, if continuity fails, a repair of the wiring between the PCM C1 and the ETCS control relay will be necessary to rectify the DTC P1659 issue. In Step 7, you will focus on the dBWRLY-CL line by disconnecting the PCM connector A. This is essential to ascertain if the wire connections are intact and functional. With the vehicle in the off-lock mode and all relevant connectors disconnected, proceed to check for continuity between the ETCS control relay's 4P socket number 4 and the PCM connector A, terminal A50. Testing for continuity will help confirm if the DBW-RLY-CL line wire is working as intended. If you establish continuity during this check, it would mean that the line is not the source of the issue, and you may need to update the PCM software or substitute a known good PCM to ensure no software glitches cause the error. If there is no continuity, repair the open wire between the ETCS control relay and the PCM to address the malfunction. The 8th step in this detailed troubleshooting guide focuses on checking for shorted wires in the VBDBW/DBW-RLY outline. As with the previous steps, start by removing the ETCS control relay from its position in the fuse box. You will again jump the SCS line using the HDS to isolate the problem accurately. Next, disconnect the PCM connector C. With these preparations in place, measure the continuity between PCM connector C number 1 and ground. If continuity exists, it indicates a short in the wiring that needs repair between the ETCS control relay and the PCM. However, if there's no continuity, it suggests that the VBDBW/DBW-RLY outwires are functioning correctly, directing you to the subsequent troubleshooting step. Finalizing the troubleshooting process involves checking for shorts in the +B DBW line. With the ETCS control relay disconnected, you need to check for continuity between the ETCS control relay's 4P socket number 1 and a body ground. This will confirm if there's a short in these wires. If continuity is established, the next step is to repair the short within the +B DBW wire, ensuring it runs correctly between the B4 fuse and the ETCS control relay. If continuity is not present, the +B DBW line is functioning correctly, leading to the final recommendation of updating the PCM if it's not equipped with the latest software. Alternatively, substituting a known good PCM may be essential to finally rectify DTC P1659. After conducting the necessary repairs and addressing issues related to DTC P1659, it is vital to verify that the repairs have resolved the problem. Begin this verification process by clearing all diagnostic trouble codes using the Honda Diagnostics system. Following this, conduct a test drive of the vehicle under various driving conditions to observe its performance. Pay attention to how the throttle responds during acceleration and deceleration to ensure it operates normally. Keep the HDS connected to monitor for any new DTCs that may manifest during or after the drive. Confirming that there are no new DTCs, along with satisfactory throttle performance, indicates a successful repair to prevent reoccurrences of DTC P1659. Implementing regular preventive maintenance routines is essential. Regularly check the ETCS control relay for signs of wear or malfunction, as early detection can save time and costs associated with repairs. Additionally, routinely inspect wire connections to the ETCS relay and throttle components, as loose or corroded connections can lead to intermittent issues. Keeping an eye out for any new DTCs during routine diagnostics can help catch emerging problems before they escalate into major failures. Effective maintenance not only extends the lifespan of the components, but also ensures smooth operation of the vehicle's electronic throttle control system. In conclusion, addressing DTC P1659 involves an understanding of the electronic throttle control system and its components, particularly the ETCS control relay. Following the systematic troubleshooting steps is essential to diagnosing the problem accurately while isolating possible causes such as faulty relays, open circuits, or shorts in wiring. Post-repair verification ensures that any issues are conclusively resolved. allowing for the safe operation of the vehicle. Lastly, embracing a culture of preventive maintenance can significantly reduce the chances of encountering similar issues in the future. Staying proactive with checks and monitoring allows drivers to maintain optimal performance from their Honda HRV. Please like and subscribe to the channel. See you next time.